Hey guys, welcome back to another Leetcode problem solving tutorial, and in this tutorial I'm going to be showing you guys how to solve question number 11, the container with most water. So this question is basically asking us to calculate, given a list of heights, which basically represent the height of these columns, we can draw a container by choosing two columns, so let's just say this one and this one, and a container is going to be, well, the width of it multiplied by the minimum height, since water can't overflow, and that's going to be the amount of water which each container can hold. So we want to, given this array of heights, we want to calculate the maximum amount of water a container can store. And obviously you can't start the container, that will just make things a lot more complicated. So we can only store water horizontally like this. So what I'm going to do is show you guys a smaller example and ignore all the actual numbers of it, but let's just look at the heights. So let's have something like this. Alright, so the basic idea for this problem is we need to use 2 pointers, one at the start and one at the end. And these are just going to sort of iterate until we can get the container with the most water. So these are going to iterate through all possible candidates for the greatest water, and we're just going to return the greatest water we get. So what I mean by this is, well, we're going to start the 2 pointers at either end. So let me actually call this left and right, just so it's a bit clearer. So the left pointer is going to start at the far left, and the right pointer starts at the far right. And essentially, the reason we start them at the ends is because this gives us the greatest initial width. So if the 2 greatest heights were on the edge, then this would of course just give us the maximum area straight away, because we'd have the 2 greatest edges and the greatest width, which would sum to give us the greatest area. But in most cases that's not going to be true. So we calculate the area by just looking at the number of spaces in between this, and in this case it's going to be 4. For example, here you can see that the height of this one is going to be 7, and the width of it's going to be 1, 2, 3, 4, 5, 6, 7. So we get an output of 49. Same sort of thing here. So the width of this is given by left minus right plus 1, or it might just be left minus right, I can't remember, because this would be at index 1, 0, 1, 2, 3, 4. So yeah, it's just going to be left minus right, which gives us the width. Okay, and then the height is going to be given by the minimum of the left and right. So if left is the minimum, then we choose this. If right is the minimum, we choose right. In this case, you can see right is the minimum. And the reason we choose minimum is because this is essentially the limiting factor, because water can't rise above this or else it will just overflow like that. So we choose the minimum limiting factor of left and right, and then that gives us the container, the greatest possible water storage in a container which is bounded by left and right. So we'd store this, and we'd store a variable called max somewhere else, and yeah, this would be our first candidate, this area here. Now here's the important thing. We need to decide whether we want to move right to the left or left to the right, like so. How do we decide that? Well, we know right was the minimum, was the limiting factor in this case, because it was a shorter one. So even if we move left, there's no way which we could get a greater area, because if we move left while it's not the limiting factor, then if we put left here next time, the total height is still going to be bounded by r, because that's the limiting factor. So the total height would have stayed exactly the same, and the width would have reduced because we moved left inwards. So as you can see, there's no point moving the non-limiting factor height, because it's not going to change the overall height, because the height is controlled by the limiting factor, in this case it's r. So what we need to do is we need to make sure we move r, because by moving r we ensure that the height is going to change. Since it's a limiting factor, then it can change to become better, or if there was an intermediate height like here, even if we move r here, well, it's gotten shorter, but there was potential for it to get larger. If we move left, there's only potential for it to get shorter. Like if we go here, then the minimum height's going to go there, and it's going to get shorter. And if we go here, well, the minimum is still going to be there. So the only potential if we move left is for the height to get shorter, height of the next container gets shorter. So there's no way that moving a non-limiting factor is going to have any good effect on a maximum area, because the width is going to reduce and the height is going to stay the same and get shorter. So that's why we move the limiting factor, i.e. the minimum of left and right. So we move right to here, now right is over here, this becomes the width, but the height is now bounded by left because left is the minimum now. So this is the height, and this is our next candidate, this area here. And yeah, you get the idea. We just check if this was larger than the previous max. If it is, then we update the max. And then we repeat this process. So right is over here now. Now left is the minimum, so it's limiting factor, so we move left inwards. And we get a new limiting height, which is taller than the previous one, but a shorter width. So we're kind of trading off, and we can't exactly tell what that trade-off is going to bring, but we calculate this new area, and if it's taller than the height, if it's greater than the previous maximum area, then we update. And yeah, we just continue this until, well, left and right are equal to each other. So again, left is the minimum, so we're actually going to move it inwards here. And it is a decrease, but that's alright, because if we moved right, well, that would have been the same thing. We would have got the same height, because this was going to become the limiting factor no matter what. So we move this here to become left here, calculate this new area. Obviously this isn't greater than the previous one, but we'll just compare anyways. And yeah, there's nowhere else to move left. Left is the minimum, so we'd move it here. But at this point, left is equal to right, so we'd break out of the loop. And I think from this diagram, we could see that when this was the position, this was the maximum possible container of water. So hopefully you guys can see the basic idea of this. We just need to remember that we use 2 pointers and we always move the limiting factor. So let's keep track of the max area. This is just going to start off as 0, and then we're going to initialize a left and right pointer, with left being the 0, 0, and right is going to be the length of height minus 1. So this is the first and last element, and then we're just going to repeat while left is lower than right, because the second they get on to be the same, we just want to break out. Okay, so what we're going to do is calculate the current area between left and right. So we already know the height, we know the width is just going to be right minus left. You can see from this example, when right is at index 4 and left is at index 0, the width is in fact 4, like so. So that's the width, and the height is given by the limiting factor between height left and height right. So we can just do math.minimum height left and height right. Not sure why height isn't getting detected. Oh, sorry, can't actually do that. Let's just say, let's call this limiting height, like so. Okay, and then we have the area of this portion bounded by left and right is just going to be pretty simply width times limiting height, like so. And that gives the area. And then what we need to do is move the limiting factor between left and right. So we'll just do if height left is lower than height right, then we need to obviously move left, so we'll increment left by 1, otherwise we'll decrement right by 1, like so. And that's basically it. Oh, and one more thing, update max if possible. So we'll just do max area equals math.max max area or area. So if area is greater than max area, it's just going to update this. And that's it. Pretty simple. You need to, the basic idea for this is to use 2 pointers and only move the limiting factor. That's the idea. And that's how we get to this. So here's the solution. Let's see how well it does against other ones. And yeah, there we go. So not the best, although we are still in this cluster. This is O of n time complexity, and we're likely causing problems because of using these math functions rather than just using if statements. But yeah, that's fine, easily correctable. And let's just have a look at what these other solutions are doing. So again, working out the width, area, and yeah, this is exactly the same algorithm as this, just written a bit more concisely, but you know, same sort of thing. That's why these times are a bit unreliable. But thanks for watching, and I'll see you guys in a future Leetcode problem tutorial. Bye!